Hey guys, my name is Ted Tryan, and today I will be showing you the tabletop mechatronics project I was assigned. It's a pretty fun project. I've had my ups and downs with it, and yeah, if you stick with me here, I'll show you everything about it and all of the steps that I've gone through to get it to where it is now. The most basic way I can describe this project is it's a separating station. The end goal is to separate out any puck that comes through into its very own bin. We do have a reject bin, a metal bin, a black puck bin, and a white puck bin. One thing that I'll show you right now with this white puck coming up is I've had a massive amount of trouble with the pucks going sideways in this chute here and creating an error throughout my system. But this will be a demonstration of what a bad puck is. It's determining the height. So the system is going to push out a puck. It's going to pick it up, push it over into the plate, and that's where it goes to figure out the height. Is it's going to this sensor over on the right, and it determines the height of it. If it's too high, the through beam sensor is going to get broken and it's going to be put in the reject bin. Now, if we have a good puck at a good height, it's going to rotate through to get to the conveyor so that it can get to the bin that it needs to go. So a little bit of a roll there, but it's okay. Made it to where it needs to go. The white puck bin is going to be on the very far right. The black puck bin, as it's coming through, that's going to be in the middle, and obviously the metal puck bin, that is going to be on the very far left of the conveyor to throw those all to where they need to go. This right here is just another view of it. I have a timer put in for when the puck comes through, because with that puck turning sideways, it would lift the plate or it would just completely grind out the motor, and it made a pretty awful noise, so I put a timer in there so that if it did spend too long right there, it's not going to go anywhere. With this white puck coming in now, I can show you that everything will stop because of the error. You'll see the flashing light, and I have my light set up. Red is the system is not enabled, green the system is enabled, and the yellow flashing means that there's an error in the program. I have the plate set up by using counters, so as you see it'll rotate clockwise. That means it's just going to be adding 1 to the positioning, so it'll go from position 2 to position 3. If it rotates counterclockwise, it's just going from position 3 to position 2. So with this one step that we see here, it's actually not where it thinks it is, and that's because I went in and changed the positioning from position 3 where it was to position 2, so it's rotating until it can find the home base. Basically where that sensor finds that reflective piece of tape there, that's how it knows it's in the homed position, and it's only going to stop when it knows it is homed, when it finally sees that reflective tape with that retroreflective sensor. Now I can go in and show you all of the errors that I have. For this one right here, if the chute does not have any puck to actually push out, it'll try 3 times before giving up. And this is actually very useful because, as you see here, I will be putting in a puck that is going to be stuck on the very edge. I've had issues with that. It's going to be stuck on the edge inside the chute, and it's just going to hang there. Once I get into position here, it's just going to hang there, and so when it gets pushed forward, it actually has enough force to knock it back down to where it needs to be so that I can get pushed forward and, grabbed and put into position for the actual plate. This one here has actually saved me a couple of times. If the puck is in there good enough to where it gets jammed, it'll try again 3 times until it actually gets pushed out, picked up, and put into position for the station transport to actually go. In this one, you'll just see that if the push arm gets jammed, it's going to set off the alarm and stop. This again just shows that if a puck goes sideways and spends too much time on the edge of the conveyor, the system will set off the alarm and completely stop. This one here just shows that if you pick up the puck or it never actually makes it to its destination, an error will go off and everything will stop. To reset an error, it's actually very simple. So once an error comes up, and we know the yellow light is flashing. We hold down the red button here for 3 seconds until that yellow flashing stops. Hit the green button and you're good to go. So here I'm just going to be showing you around the HMI. We will sign in with the supervisor login, put in the password, hit enter on that, wait for the main button to appear. We'll click on that there, head into our main page. So as you can see here, we have a start button, we have a stop, hold to reset button, a metal puck counter, black puck counter, white puck counter, and a reject puck counter. We also have the reset the efficiency on it. We can reset the counters on it. We have our system faulted, our station transporting, and system enabled light. We'll hit start real quick, show you that the errors do work on this. We'll make that error there, so it says that we don't have anything to push out. We're empty. We need to fill that up. So I'm going to fill that up real quick, put a few pucks in there for you. And if we hit start, nothing happens. We got to hold down this button for 3 seconds till that system isn't faulted anymore. Hit go, baby, go. And on our way we are. So you can see another error pop up here that, it stayed in that position too long. We need to clear that before we go again. I accidentally did kind of set off the white counter there by accident. So we're gonna try with the black puck here. You'll see the black puck counter go up. Again with the metal here going across. We're gonna try that white one more time. And you can see because of our error on the first one, our efficiency is pretty low. And so now that we got all three in, I can show you if we log out real quick. Same deal. You're gonna have to sign back in with a different user. It's a pretty simple HMI and works good. So now I'm just going to be showing you around the AutoCAD drawings. We have our PLC on the left there, inputs and outputs. On the right here, we have our DC power supply, along with our incoming power of the 120 volts and our neutral. We have our second drawing right here. Very similar, set up on all three. Our inputs, outputs are pretty similar, just difference in what they do. Our inputs are very similar, just what they're hooked up to. Same on the power supply, and on the third here, just a little bit of a difference with our contact relays, but everything is still pretty uniform, pretty the same. And it was based off of a wiring diagram I got from a manual. So the main routine here in my programming is in charge of the subroutines. The delays, jams, and errors routine here is in charge of the errors, making sure, using timers, just make sure that everything gets to where it needs to go in the correct amount of time and nothing spends too long when it's not supposed to. Heading on to the home plate, this entire subroutine just controls the red rotational plate, making sure it does what it's supposed to. Moving on to the messaging, nothing fancy here. And then we go on to PLC 1. This controls the suction arm, all of the transporting. PLC 2, this will determine where it needs to go, if it's a good-sized puck or a bad-sized puck. And finally, PLC 3 here, just determining which bin it needs to go in once it finally hits the third station. But this is basically it for my PLC programming. And with that, we can head into our final topic of discussion, our operator's manual. As you can see here, we have everything between our introduction, startup, and errors. If we scroll down, we can go to Station 1 and its operator's manual. We have our introduction, setup, and process, just explaining how everything works and how the Station 1 is in charge of first contact with the pucks. And here we have the AutoCAD drawing. Moving on to Station 2, we just have the same things that we had for Station 1, plus the AutoCAD drawing as well. And on to Station 3, again, we just have the introduction, setup, and process. The final item is our AutoCAD for Station 3, and this comes to the conclusion of my video. One thing that I think went very well would be Programming when I didn't program myself into a box. Josh helped me a lot with that. One thing I wish I would have been able to fix is the efficiency of the station. Those pucks moving from horizontal to vertical, where they should have stayed horizontal, was really frustrating, but I don't think that my programming could have fixed anything about that. But other than that, I think that it went pretty okay for the most part. Working with Micro 820s isn't really all that fun with Connected Components Workbench, but I make do with what I have. And with that, thank you very much for watching.